to Dear SQL DBA, a podcast for and about SQL Server database administrators. Today we're going to talk about index tuning in SQL Server, and specifically a really useful view for index tuning, the index usage stats view. But this view, does it tell you what you think it tells you? Our question today is as follows. Dear SQL DBA, why does the Stats.DMV index usage stats dynamic management view increment the user updates value even when you have a where clause on a given index that would result in no change to indexed values by that query? Sincerely, Going Insane with Index Usage Stats. I'm Kendra Little, and today's Dear SQL DBA is about one of my very favorite topics, index tuning. So we are going to talk all about the index usage stats DMV and its many little quirks that could make you feel insane. So it's okay if you don't use this DMV all the time or have never heard of it. We're going to give you a little bit of an overview at first. What does index usage stats do overall? Well, since SQL Server 2005, we have had this dynamic management view, which is a built-in view in SQL Server that whenever your SQL Server database comes online, starts tracking which indexes are used by your queries and how does it use them. Now that sounds simple, but as we'll talk about, the devil is in the details. So first up, our question is about the user updates column in the view itself. And let's start with what the documentation says, because part of the heart of the answer to our question is actually tucked away in books online. It's just a little cryptic. So on the sys.dmdb index usage stats DMV, on the page, it says, hey, user updates, here's what it is. And there's a long quote here. User updates is the number of updates by user queries. This includes insert, delete, and updates representing the number of operations done, not the actual rows affected. For example, if you delete 1,000 rows in one statement, this count will increment by 1. So that's all in books online. And what it's trying to say is the user updates column will tell you how many inserts and updates and deletes happened, but it won't tell you how many rows were affected, just the number of statements that had an insert, update, or delete operator for that index. Now, the example they give says if you delete 1,000 rows, it increments by 1. What we've noticed, the question I got from, Insanity in the index DMV says, hey, even if I delete 0 rows, that counts as an update and it counts by 1. And yes, that's by design. That's not the exact example they give in books online, but the heart of your question is, this isn't telling you, hey, how many individual rows did I modify? This is simply telling you, hey, we had an operator that maybe did a modification. Maybe it modified a lot of rows. Maybe it didn't modify anything at all. To figure out, we're going to have to dig deeper. Now, what I want to talk about today is that index usage stats this is just the beginning of its weirdness. We also have columns in index usage stats for user seeks, for user scans, and for user lookups. So it is a little more specific when it comes to things that aren't modifying. Like it lumps inserts, updates, and deletes all into this single column about updates. But we have multiple columns for seeks, scans, and lookups. It does categorize them all by user, and that's really useful. There's another set of columns that are for system, that are more for like background things that are making the SQL Server work. So these columns for user updates and user seeks, user scans, user lookups are all queries that our applications run or that our jobs run or that we run in Management Studio. So it's not just SQL Server maintaining the index in the background. The devil is in the detail here, though. So similarly to the issue with the delete, there's another weird issue that, like, let's say the user seeks column. Just because I see that user seeks column has a value in it doesn't mean that those seeks were actually executed. So here's an example of how that could happen. Just because an operator shows up in an execution plan doesn't always mean that the operator was actually executed every time the query ran. Let's say I'm doing a join and SQL Server sees that there's an index that it can use on each side of the join, and it decides to do a nested loop operator. And the way that this particular join is going to work, for every row that comes in, it'll pick one of the indexes as the outer index. And for every row that it finds in that outer index, it will go, and in our case, it will perform a seek on the other index. And that nested loop, for every row that comes in from the outer, it's going to go perform a seek on the inner index. Well, let's say when our query actually runs with this nested loop, that 0 rows come back from the outer index. SQL Server is smart enough to be like, hey, I have to execute this 0 times. I am never going to actually execute that seek. It doesn't just like go do it for the heck of it. But even if this happens, in the index usage stats DMV, we are going to see the user seeks column increment by 1. Because similar to what was happening in the delete, even if the delete actually didn't touch any rows, what it's trying to say is, hey, you ran a query that had a seek against this index. There was an operator doing a seek, and you ran it once. The operator appeared in the plan once, and you ran it this once. So I'm going to count that as 1. If our nested loop operator, let's say it found 10,000 rows in the outer table and it executed the seek 10,000 times, in index usage stats, that would still count as 1. It doesn't matter how many times it actually had to execute the operation. Index usage stats is just representing, hey, this operator was in a plan in a query that ran this many times, right? But it gets even weirder. We have another column called user scans. Now, user scans sounds kind of straightforward at first, right? When we're taught indexing in SQL Server, we're taught, and maybe part of this is just assumptions we make from the words. We assume that a seek is really efficient and that a seek goes straight to a small amount of rows it needs. And we assume that a scan must read more rows. It reads every row. This isn't necessarily true. The user scans operator is simply telling us, hey, you had a scan operator appear in the execution plan, but it isn't telling you that it read every row. It doesn't necessarily read every row. So let's say we have a query with a top operator in it. And in our case, let's say we want the top 10 rows that meet a certain set of criteria. The SQL Server creates a plan for this, and it has a scan operator that feeds into the top operator. And the SQL Server, again, it's clever. As soon as it finds 10 rows that fully meet the criteria of our query, it is smart enough to stop the scan. It's like, hey, if I have met the requirements and I have the 10 rows that you wanted according to all of the predicates and order by in your query, I don't need to scan anymore. I'm all done. Let's move on. I might have an index that's 10 gigs and a query that does a scan and a top operator, and my query might find the data that it needs to satisfy the query in reading 3 pages and be done. That would still increment user scans as 1 in index usage stats, and I would have no way just looking at index usage stats to know, did it scan the whole thing? Did it scan just a couple pages? To find that detail, I have to look at the exact queries that are running against it and perhaps other metrics from the SQL Server. So user scans doesn't mean it read the whole thing either. And another weirdness. The index usage stats DMV doesn't know or care about rollbacks. So let's go back to the example from Books Online. We have a query that updates 1,000 rows, except this time when we run the query, before we run it, we say begin tran. Then we run our update statement. It updates 1,000 rows, and then we run rollback. So it undoes every update, and it's as if it never happened. That will appear in index usage stats the same way as if I committed that transaction and the update stayed there. It will increment either way. Index usage stats will increment user updates by 1. It isn't aware that it was rolled back. It doesn't care that it rolled back. It's just like, hey, a plan ran that had an operator that did a modification. I don't really care if it succeeded or not, right? I don't really care. So really, what all of these things together, these are actually all kind of consistent. When you put them all together, there is a consistent picture of what index usage stats, the dynamic management view, shows. It shows you the count of different types of operations, just the number of operators that did something in an execution plan. It isn't measuring exactly how many times they were individually executed or how many rows they updated. It's just, hey, this is the number of, kind of references to this. This is the number of times that you had an operator about this show up in a query plan. This is a really big picture view of what indexes are you using the most and generally in what ways. But when you really dig into the individual types, to really figure out what's going on, you're going to have to dig into either traces or other views in SQL Server to really get the details from it. It's just helping you see, hey, what's popular from the big picture view and what indexes or tables are not popular at all. So I really love this as a big point, a big arrow of you use these indexes all the time and you don't use these indexes all the time. So if I am thinking about where can I potentially reclaim storage to make my backup smaller or to make it easier to restore my database somewhere or to make my maintenance take less time, I'm going to look for a list of indexes that haven't been used much at all, and I'm going to put those on a list where I keep watching them to make sure that they're not really used much. Or similarly, if I'm looking at an index and I want to add a column to it or change the order in the columns, I want to know how big a risk is that? And knowing how popular it is with queries gives me really quick insight into kind of knowing how careful do I need to be when I make this change. And index usage stats really, really helps with that. But just because life can't be too easy, there is an issue with bugs we've had about when index usage stats gets reset. So when this view came to us, when we got the index usage stats DMV in SQL Server 2005, it was just reset for indexes when the database went offline. So if you fail over the SQL Server or you restart the SQL Server, take the database offline, that would reset it. It was since the last time the database came online. But when SQL Server 2012 was released, there was a bug in SQL Server 2012 RTM where anytime someone runs an alter index rebuild command, it resets the usage stats for that index. And this is kind of a big bummer because people tend to set up maintenance to only maintain indexes when they get really fragmented. And they might, I could have one index that was rebuilt last night and another index that was rebuilt 2 weeks ago, and a third index that hasn't been rebuilt since my SQL Server came online 4 weeks ago. And I don't have a good way to know when were these indexes last rebuilt. If whoever set up my maintenance carefully logged it, I might be able to look it up, but SQL Server doesn't track that for me. Now, the good news is Microsoft is fixing this bug about alter index rebuild, clearing out index usage stats. A fix was released for SQL Server 2012, and 2012 is the first place it occurred, where Service Pack 3, Cumulative Update 3 fixes this issue. SQL Server 2014 still has this problem. Service Pack 2, which hasn't released yet as of this recording, it's a planned release, it is said to contain a fix for this that we are going to get. And good news, the SQL Server 2016 RTM version fixed this issue. The problem doesn't occur in 2016. So you can, as long as you're patched on 2012 and as long as you look at the next service back on 2014, this will get a little simpler and you'll be able to go back to a world where, okay, it's how many times has it been used since the database last came online. So let's circle back to sort of the intent of our question. The intent of our question was really, what if I care and I want to know more detail about how many rows were actually updated? So like if it updates 0 rows, don't count those. And if it updates a lot of rows, do count those. How could I figure that out? Well, index usage stats isn't really a great way to do that. You can get that if you really care about that. A trace is one of the best ways to be accurate about that. You could use ye old SQL trace, or you could use extended events to trace that. Now you are going to have some impact on your server by doing a trace. And I would be very careful, and I wouldn't trace execution plans, which is likely to have a deeper performance impact on your SQL server, because even if you try to filter, it still looks at them all. Be very careful, and I would just collect write information about which queries are doing writes. I would not collect execution plans. Another good way to get detail, but less complete detail and slightly different detail, would be to look at other dynamic management views. To look at the sys.dm exec query stats dynamic management view, which will record information about the number of writes a query does, and you could join that to the query plan dynamic management view and say, okay, I only want to see queries that reference this index. Now you're going to have to do some work and filter out and say, well, because the query might be reading from that index rather than writing to it. So you're going to have to do some digging there. But I like this perspective because getting into the query plans and looking at the queries themselves gives you the type of information that you're really asking about. What are the queries that are modifying this, and what's up with those queries is sort of related to the heart of your question. You're not necessarily going to see every query that does a write to the index either, though, because execution plans can get removed from cache by memory pressure or by different things happening in your SQL server. But I do like this because it gives you access to rich things like query plans without really dragging your SQL server down doing a trace. So if you're interested in this one, Grant Fitchie wrote a great post on how to do this. The good keywords to find his post are Grant, querying the plan cache simplified. If you are driving right now or doing laundry, don't grab a pen. Keep driving. Keep doing laundry or cooking dinner or whatever. If you go to littlekendra.com/Dear SQL DBA, I have notes on every episode, including clickable links, like a link to Grant's great query where you can say, okay, I want to see information about the queries in cache that have referenced this specific index name. Now, another method that is going to increasingly become a good way to solve this is turning on tracking with the query store for your database and having it collect information about the queries that are running, including the plans and who's doing how many reads and writes. If you have query store running against the database, you can take backups of the database, you can restore them elsewhere, and you can query all that query store table information to say, what kind of modifications are happening to this table, and if you want the plans and more information about the queries, that is in there as well. And I love the fact that you can offload that analysis by restoring the database. So that, I think, as it's only available in Azure SQL Database and in SQL Server 2016, but that increasingly is going to become a really popular way to do this because, hello, that's kind of awesome. A way that I don't use. Now, I include this mostly because some of my listeners are going to be fans of dynamic management views in SQL Server, and they are going to say, hey, Kendra, what about the operational stats DMV? Why can't I use that? Well, you can look at the operational stats DMV, but for things like how many writes are happening, I have found it to be pretty frustrating to use personally for this purpose. The Stats.DMV index operational stats DMV is kind of like a cousin to the index usage stats DMV that we've been talking about so far. So operational stats is just much more volatile. And if you look at its documentation, this is not a bug. It's known, when they designed it, they say basically, when a table leaves memory or an index leaves memory, the information from operational stats is going to be completely reset from it and disappear. And this can happen anytime, and you don't get like the date that it was last cleared. So you could be looking at this and memory pressure happens, and then suddenly the information that you're looking at totally changes. That's just by design. So you can look at sys.dmdb index operational stats, know that it's super volatile, and okay, how many writes since when? Really, really confusing. If you're going to put the amount of time into investigating into that, I think your time is a little better served by doing either a trace or looking at the query plans DMV and DM exec stats, just because you get more information about the queries and the query plans from looking at, the query exec stats DMV, or if you choose to use the trace, you at least get very complete, accurate information. So I kind of feel like for this purpose, for this problem, the operational stats DMV is a little frustrating for the amount of time it'll take you to kind of sort through it and scratch your head and say, wait, now the data is all different. All in all, big picture, index tuning can be complex. The index usage stats DMV just kind of gives you big picture information on how many times did a query plan reference this index. But that information is insanely powerful, and you can get it instantly. And that is really, really cool. If you have an active SQL server running, you can take samples from this and see, hey, these indexes are the ones that have been used in the last 5 minutes. And that is insanely cool. You can add a new index and see, have plans been referring to this right away? I love that. I will continue to love that. And even as we get like new great toys and tools in SQL Server, the index usage stats DMV is going to stay relevant and stay useful. So it's worth sticking with it, getting to know it despite its eccentricities, and investing your time in index tuning, because you can get huge performance gains, and this DMV can be a big help. Thanks for joining me this week on Dear SQL DBA. I'm Kendra Little, and I'll see you again soon. Music for this episode was provided by Scott Holmes. If you would like to support Dear SQL DBA, I would appreciate it if you took a moment and wrote a review on iTunes. Just search iTunes Dear SQL DBA.